the stairs are like pure grade. You're like, okay, done. I mean, you're looking at the grade, you're looking at the rise, you're looking at the run. Now think about a road. You're on a road, you're in your car, you're trying to figure out the grade. What are you looking at? When you're in your car looking at the road, what part? You're not, though. That's the trick. You're not looking at the well, the tangent would be the rise and the run divided. You're looking at the hypotenuse. Yeah. You're looking at the hypotenuse. And it was either Ashley or Jessica. You said about you were looking at the hypotenuse, and it was totally different. So here's the deal. Here's the deal. Let's go back for a moment to College Way. Back for a moment to College Way. Okay? 6%, if I remember correctly, right? So let's just say that that's 6 feet over 100 feet. Just to make the numbers as simple as they can be. They could be any ratio that makes 0.06. Could be 3 and 50, could be 60 and 1,000, doesn't matter as long as it's 6%. Can you figure out what that length has to be? Now, you could say no or you could say yes. It depends on how much geometry you remember from high school or whatever your last math class that did this was. But you can remember, you can figure out what that last length is using a really, really, really cool thing that you may have forgotten. Starts with a P. Go ahead, Christy. Is that what you're going to say? Absolutely. There's something called Pythagorean theorem. It's a beautiful little thing. You probably remember it as a squared plus b squared equals c squared. Not a problem with that. I'm going to rephrase it, though, if it's okay, using our new language. Run squared plus rise squared equals hypotenuse. All right. You guys like long side better, don't you? Well, I already started writing hypotenuse. Hypotenuse squared. Hypotenuse is a fun word. Fun word. So if you know 2 of them, you can find a third. Fair enough? Fair enough. Run squared plus rise squared was hypotenuse squared. Well, we know the run and the rise. The run's 100. The rise is 6. I think we can figure this out. Let's work on it together. Run squared. Well, the run is 100. That's 100 feet, and that's going to be squared. Rise is 6 feet. 6 feet. That's going to be squared. And that's going to be equal to this unknown thing. And I think you guys like X, if I remember correctly. You don't like the question mark, smiley face, and stars. You like X. Call it X. Okay, cool. Equals X squared. So 100 feet squared is what?
1,000.
One more zero.
10,000.
10,000 square feet, believe it or not. It's actually square feet, isn't it? Because you're squaring feet, which becomes square feet. But we'll ignore that for now. I have a whole project devoted to that because I realize that people don't pay attention to those kinds of things. In math classes all that much. And it's not your fault, it's the curriculum. So we'll have a whole project devoted to dimensional analysis. I'll just call it 10,000 just for grit, it's square feet is the unit, but we'll ignore that. As long as you know that at the end of the day we're going to have feet when we get here. That's what we have to get, right? Good. So it's 10,000 plus
36.
Yes, 36 equals x squared, whatever that is. So it's 10,036 feet is equal to x squared. So what we have to do is we have to figure out what the square root of that is, don't we? Now if you got your TIs, of course you can do that. If you've got a cell phone, you can do it there. I'll show you how to use Google to do it. It's also extraordinarily cool to use Google to do this kind of stuff. I'll fire up Google real quick. Blank screen, escape, Firefox. If you just go to Google, up here in the search bar, there's an old command back from the days of basic programming. SQRT is square root. So you can simply type SQRT and then put the number in, and then it'll tell it to you. It'll give you it's right here. It's 100.18. That would be the hypotenuse. If the rise is, you got your controls down. That better? So it just solved the equation for you. If you can set the equation up, it'll give you the numerical solution. And the numerical solution is 100.18 feet. 100.18 feet. So we now know what the hypotenuse is, don't we? 100.18 feet. I'm going to put a squiggly equals because it's approximately equal to that. It's not exactly equal, is it? You don't have to run the squiggles if you don't want to. I tend to do that when I have approximations, which life is full of, as we kind of figure out. Now, here's a question I have for you guys. How much different is the run of 100 feet versus the rise of 100.18 feet? It's not that much different, is it? As a matter of fact, if you were to calculate the grade based on the hypotenuse, what would you get? So what I like to call this the wrong way. The grade calculated the right way is the rise over the run. We've been talking about that since last class, yes? It's the rise over the run. And I only call it the right way in quotes because that's what it's been defined to be. The wrong way is by using the hypotenuse over the, it's the rise over the hypotenuse. In other words, you switch out the run and replace it with the hypotenuse. Now, why would you ever do this? Because it's all you have. I love that answer. It's all you have. Megan?
Well, so if you know the rise, if you have a sign and you know how far you went.
You're driving on the hypotenuse.
Right.
So that's what you have access to. It's all you have. I love the it's all you have comment. Tell me your name again.
Michael.
Michael, go, and then
Anya.
Anya. Yes, go
I
ahead.
was just going to say that, well, at least in this case, the run and the hypotenuse are almost equivalent.
And that's why it's okay to do the wrong calculation in most cases.
Approximation.
In approximation. But then we come back to what Jessica said. You were going to say something else.
Oh, I was just gonna say, I mean, using the equation that you gave us,
Mhm.
we just,
Yes. You could just find. Now you could, if all you knew was the hypotenuse,
right, and,
you could find the run, couldn't you?
yeah.
So suppose, for example, this is a bit fictitious. I told you this was 6, I told you this was 100. In reality, you're not going to know that that's 100. You're going to know what you traveled on the road, and you're going to know via either an app or something else how far you've gone up. You could easily use this equation to solve that. I got a quiz plan for you guys in a couple weeks for that. Yeah. Oh, I've got that plan if you choose that adventure. I mean, that's going to be what I want you to do at some point. But the idea, I want you guys to calculate it really quickly, if you would. Calculate it the wrong way on these two numbers right here. So divide the rise, which is 6 feet, by the hypotenuse, which is 100.18 feet. And I'll do it with you using Google. You just simply type in 6 divided by 100.18. Same calculation you're doing, right?
Yeah.
5.989%, which rounds to 6. If you go out 2, 3, 4, or 5 places, it still rounds to 6, doesn't it? Which means there's not much of a difference in checking the wrong way or right way. But here's the caution I have for you. There's not much of a difference so long as it's a relatively small angle. There would be a huge difference. There would be a huge difference with a larger angle. And that's what Jessica made a note of when she was checking the staircases. Let me give you an example of where the wrong way can affect, if you would. And I've got an ADA quiz, an ADA ramp quiz I want you guys to analyze. I got a lot of great quiz ideas. They're fun. They tend to be very applicable to your lives. Like, for example, when they put an ADA ramp, that's why I was measuring that while you guys were checking your stairs. I was checking the ADA ramp. I'm going to have you guys run the numbers on that to make sure that Gene Zinkraft, love you, Gene, when he poured the ADA ramp, to make sure that it was actually done correctly. You have to make sure of that, right? So, the right way and the wrong way. Suppose, you guys had some pretty steep stairs. Some of you. And we didn't even do the steepest stairs on campus. Do you guys know which building has the steepest stairs on campus? I don't know how they made these. Ochako. Ochako, right outside of 123. You want to get your heart pumping.
No, geez.
It's only about 10 stairs. But I think, and I haven't measured them yet, maybe if I can remember on the way up to Modoc, I'll measure them today. If you look at those stairs in Ochako, they're essentially just as deep as they are tall. So in other words, it's a 1-to-1. For every 12 inches in, it's 12 inches up. I mean, you are really, I was joking with somebody as I was talking about your quiz. I was standing on the picnic table, walking up on the table. That's what it feels like at Ochako. It's like you're walking, you're like, holy crap, I'm going up very fast. Like my heart is boop, boop. So in other words, for every one something you run, you also won the same something of rise. So what would the grade of this be? I'd vote 50%. I have a vote for, let's do it right way. Right. Rise over run. What's the rise? 1 something. What's the run? 1 something. What's 1 divided by 1? 1 as a percentage. It's a 100% grade. A 45-degree angle is a 100% grade. I very often ask students, what's a 100% grade? And almost always they go like this. That's not 100%, that's infinite. That's an infinite grade. It's all rise and no run. 1 divided by 0, which is infinity. Well, we'll talk about that over coffee. That's a 100% grade, correct? Now, suppose you did it the wrong way. What's that? What is that right there?
It's still 1.
The grade right way is still 1, but suppose you use the hypotenuse. Now, the first thing you have to do is find the hypotenuse, right? So this guy right here, you'd have to do 1 squared plus 1 squared equals that squared, correct?
Yeah.
Okay, equals x squared. Okay, that's 2 equals x squared. So it's the square root of 2, which is about, I think it's about 1.4 and some change. Let me check using Google. I'm pretty sure that's right. Square root of 2, oops. Yeah, 1.41-ish, somewhere in there. With me so far? So if you did it the wrong way, rise over hypotenuse, because remember, if you're on a road that's this steep, you wouldn't have this run. You could use your app on your phone to tell you how much you rose. But you'd have to use the odometer in your car to tell you how much you hypotenused. You couldn't get the run, right? The run would be hidden from you in the earth. It's different measuring stairs. Stairs are easy, right? Stairs are easy. So the wrong way would be rise over hypotenuse, which is 1 over about the 1.4. Now look at the difference now. When you do, I'm going to cheat a little bit. I'm just going to go 1 over square root of 2. That'll give us a nice exact answer. 71%. 0.707 is 71%, yeah? Well, that's a hell of a lot different than 100%. It's still really steep, but it's a hell of a lot different than the 100% that it actually is. So the answer is, as the angles get steeper and steeper, the wrong way and the right way become different. But when they're extraordinarily close, like on roads, you can generally do it the wrong way, which is easier, right? It is easier to do it the wrong way. Yeah, Amy.
Why in our homework quiz do you say the right way is using the hypotenuse and the wrong way is the other way?
All right, read it again. I've got it set backwards, right? Look at the first one. It says
Yeah.
use it the wrong way. Use the 6.5 miles as the run. So I'm saying treat it as if it were the run, which means you're doing it the wrong way. Fair? So what Amy's referring to is the quiz due Wednesday deals with this, the wrong way and the right way.
Okay.
I see what you're saying, but I'm saying pretend the hypotenuse is the run, which makes it the wrong way. Pretend that is the run. Cool? Does that make sense, Amy? Great question. So the thing about it is the wrong way, which is fantastic to use because it's so simple, it's okay to use so long as you're not getting too far from vertical. So long as you're not getting too far from vertical. Yes?
So if I know that Pilot Butte goes up 500 feet, and it's a mile long, would that give me an accurate rate of like 9%?
Roughly 10%, somewhere in there. It would give you a good ballpark if you didn't need exquisite precision. Hold tight on that one. And we're going to analyze Pilot Butte in here too, because that's another great question to analyze is looking at Pilot Butte. There's so much applicability of grade to your lives. Fair enough? Tell me your name one more time.
David?
David? That's what I was going to guess. Yes. Okay, good. I was going to guess correctly. One last thing, just to wrap up. And it ties back to the quiz Amy just mentioned. And also, believe it or not, it ties back to what David just mentioned. If you didn't hear what he said, he asked about Pilot Butte. You guys hiked Pilot Butte before?
Oh, yeah.
Yeah, it's a fun hike. It's fun. It's about a mile long hike. Ish, right? Ish. About a mile, it's depending on where you start. I mean, I bike it from the bottom to the top, which is a little bit longer, I think, but whatever. It's about a mile. Use a mile as a... And you gain about 500 feet, as David said, right? So for a ballpark, if you treat the mile as 5,000 feet-ish, and the height as 500, that would be what grade? 10%. 500 divided by 5,000 is 0.1, which is 10% as a percentage. That's the wrong way to calculate it, isn't it? Because you use the 1 mile. Think about what you're on for that mile. You're walking on the trail or you're driving up the road, which means you're on the hypotenuse. Huh? You're on the hypotenuse. Later on, we'll analyze it both ways, the wrong way, the right way, and decide if there's a difference. I mean, of course there's going to be a difference. The question is it ignorable? Can you ignore the difference, right? And the answer is yes, as long as the angle's pretty small. Now, going back to Amy, she's already looked at the quiz for Wednesday, which analyzes my commute from my house to COCC. When you actually calculate the grade of that commute, you're going to be unimpressed by it. Because it's very small. It's in a single-digit percentage, is very low. There are sections of it that are exceptionally steep. That's because average grade is different than instantaneous grade. Archie Briggs Road, remember that crazy steep section I showed you on Archie Briggs Road, 17 or 16.5%? Just the one section. There are also sections on that road that go downhill before going back up. But average grade ignores all that. It simply goes from the beginning to the end and looks at the overall change in elevation and distance. So I'll give you a perfect example of one of these to leave you with today. How many of you guys have ever ridden, hiked, run the Mackenzie River Trail? It's, according to their website, it's the most popular trail, it's the best trail in America.
It is amazing.
It is amazing. I'm always nervous about telling I'm the best of anything. It's a wonderful, wonderful, wonderful trail. I like riding it whenever I can, which is not as much as I like to anymore now that I have Max, because he slows us down a little bit. But it's okay. My wife, whenever I mention Mackenzie, she's like, oh my God, that trail is so uphill. I'm like, babe, if you look at the elevation map, I mean, if you start at Clear Lake and you end up at Paradise, you've gone about 24, 25 miles, and you've dropped, here, you've dropped from 3,200 feet to 1,450 feet. So what is that drop? What's the drop? About 2,000. Let's call it 2,000, make life easy for us. Make life easy. We can get more precision if we need. You drop 2,000 feet. Over the course of 25 miles. So you'd have to be careful. You don't do 2,000 divided by 25. You have to do 2,000 divided by 25 times 5,000-ish, or 5,280 if you want to use precision, right? Because it's 5,280 feet in every mile, and you travel roughly 25 of them. So the grade, even if you were starting at the bottom and going up, the grade of the Mackenzie River Trail, let's use Google again to help us, would be that 2,000 feet divided by, let's make this all at once, 25 times 5,280. Cool so far? See how you can use Google just like your TIs? It's so nice.
That's not.
Okay! So 1.5%. Babe, what are you complaining about? 1.5%. Right, Kurt? It's 1.5%, baby. I mean, I don't understand the complaint. You know what her, and this is legit. This is her complaint. Can you see her complaint? No, she doesn't want 25 miles. She tells me, oh my God, it's so steep. She points to that section right there, where you do have to go uphill very steeply for a very small section. That section right there is pretty damn steep. But I'm like, babe, you end up lower than when you started. It's like, it's downhill. Oh, but that's the beautiful thing. I'm talking of the average grade of the whole trip. The average grade of the whole trip is 1.5%. She only remembers that because she keeps going uphill. You see?
Clearly just like a minute that you're doing that.
It is, but it feels like an hour because it's so hard, right? And that's the perception, right? That's why you have to be careful. Are you expressing average grade or are you expressing an instantaneous grade? More on that coming up soon. Average versus instantaneous. I like those, comparing those two. Cool? So now you can totally nail that quiz for next week. Yeah, let's make piles. Just make them up here if you would. Let's do in-class quizzes, maps, pictures, tapes. And we'll see you guys Wednesday. I'll try to send the mass email out. Assume we're going outside though, okay? Assume we're going outside. Wear pants. Pants. Math 105, pants. It's gonna be our cheer. Let's even cheer. Pants. Thank you. I like these quizzes. I like making up new quizzes for it. Based on what you guys enjoy. It makes me happy. Yes. That sounds about right to me. And what'd you get for the other one? About the same? It's a big 0% error because we're almost doing the same. That's what it should be, right? That's what you have to do the right way. Look it up in the table. So you have the grade now, it's 2%. Just go to that thinking table if you're just Google thinking table and go 2%. Yeah, an average. Cool. Excellent. Yes, let's sign you in, my friend. Alright, what's something over the pencil? Oh, here we go. Got it. I knew I had one. Thank you. 6:14. Let's get you this class. Excellent. Thank you, guys. Hi. It didn't show up. Well, let me bring this with me then. And your name is, yes, Jessica. What's the last name? Heitman, Jessica. Yeah, I don't know what happened there.
It's the Weaver office, I assume.
That's exact. So just here's an easy solution. Just convert the PDF before you upload.
I got that now.
Yeah, that's an easy fix. Somebody was using OpenOffice as well. Same thing. It was showing like 9 versus 10.
Yep.
I don't know why. I think we got to fix them.
Thank you.
So
welcome.
the front is figured out how you convert it to PDF.
Correct. Correct. Absolutely.
How do I convert it?
No. And look on the back. You see where it says points on the back? There's no points on the front, right?
That's true. I don't
Yeah.
have boxes.
You'll get used to this. You'll get used to this because a lot of times when I'm writing along, I'll say like, hey, what do you think? If there's no points attached to it, you don't have to do anything.
So I have another question.
Yes.
So if you're trying to find a grade or something, you don't have like a stairs, or if you don't have a garage, like College Way and stuff, how did you?
I use my clinometer. So there's a tool that I own that actually does the math on
Okay.
it. But that's why the wrong way versus the right way is so important. College Way, you can do it the wrong way, so get the correct answer. So you can start at the bottom with your cell phone. Shoot an elevation, have it tell you what your height above sea level is. Drive to the top, shoot your elevation again. Now you've got a difference, you know how much you climbed. Look at your...
do that with my phone.
Oh, you have to put an app on it.
Okay.
Just go for elevation app,
Yeah.
and you'll get a free one.
Okay.
And I'll show you.
Are
I think I can
you
show
gonna
you.
be in here for a minute? Are you gonna be in
Yeah,
here?
I gotta pack up for sure.
We were wondering if you could